You don't need Kubernetes. I know that's hearsay in 2025, but hear me out. At NASA, we had brilliant engineers spinning up complex orchestration systems for teams of 5 people. When funding cycles shifted, those systems became maintenance nightmares that consumed entire sprints just keeping the lights on. Your mid-sized company is probably making the same mistake right now. You're building enterprise infrastructure for startup-sized teams, and it's quietly killing your velocity. Today, we're talking about platform engineering that actually fits companies in the missing middle. Not vendor pitches, not conference-driven development, just what works when you've got 200 to 1,000 employees and need to ship products, not maintain infrastructure. I'm Tom Barber, and this is Engineering Evolved.
Welcome to Engineering Evolved, where business meets innovation and technology drives transformation. Each episode, your host, Tom Barber, explores the challenges and opportunities facing the organizations in the middle, the forgotten ground, where startup rules no longer apply and enterprise playbooks are far too large. From scaling systems and leading teams to aligning engineering with business goals, this is where practical insight meets real-world experience. Engineering Evolved, guiding today's leaders through the evolution of engineering.
So welcome to this episode of Engineering Evolved. This is episode 11. I'm Tom Barber, and today, as you can see, I'm not in the office. I'm in the UK on a boat. So I do own a boat in the UK. I enjoy sailing, and I'm on my way to help out a customer in Poland and work with their team. And so this is a useful stopping off point on the way over from the States. This show is for engineering leaders at mid-sized companies who are tired of advice that only works for enterprises or startups. Today's topic is platform engineering, but we're not doing the usual CNCF project bingo card. We're talking about what actually works when you have real constraints, limited headcount, finite budgets, and a business that needs features shipped, not infrastructure admired. We'll cover the build versus buy framework that helps you make platform decisions without regret, how to right-size your infrastructure so it serves your team instead of consuming it, and internal tooling that actually matters versus the stuff that just looks good in a tech blog. By the end of this episode, you'll have a framework you can use Monday morning to evaluate every platform decision your team is facing. So let's get into it. So before we dive into frameworks and decisions, I need to tell you about a story from my time at NASA's Jet Propulsion Laboratory. Not because it's a success story, but because it perfectly illustrates what goes wrong when smart people over-engineer platform infrastructure. We had a small research team. It was 3 or 4 engineers working on a data processing pipeline for mission analysis. Someone on the team had come in from a big tech company and was excited to bring modern practices to JPL, which in practice meant Kubernetes, service mesh, custom operators, and a lot of YAML. But the problem is that whilst the system worked, it was technically impressive. We could scale containers, route traffic dynamically, and handle complex deployment scenarios. The infrastructure itself was absolutely enterprise grade for about 6 months. Then the funding model for that particular project shifted, and NASA operates on mission cycles and congressional budgets. So projects don't just gradually wind down, they hard stop. And then half the team got reassigned to other missions. The person who built the Kubernetes setup moved to a different lab. And suddenly we had just 1 or 2 engineers trying to maintain this intricate orchestration system that was designed for a problem we didn't actually have. Deployments that should have taken 5 minutes took an afternoon because someone had to remember how the custom operator works. Debugging a service issue meant tracing through 3 layers of abstraction. And so we end up spending more time maintaining the platform than we spent building the features for the actual science mission. Eventually, we ripped it out, replaced it with standard Docker containers running on VMs with a simple bash script for deployment. It was boring, it was unsexy, but it took 20 minutes to onboard a new engineer instead of 2 weeks. And that experience taught me something crucial. The sophistication of your infrastructure should match the sophistication of your team's needs and capacity, not the sophistication of the tools available, and definitely not the sophistication you think you might need someday. Mid-sized companies face this constantly. You've got engineering leaders who came from Google or Facebook trying to replicate what worked there. You've got vendors selling you enterprise platforms. You've got developers who read tech blogs and want to work with the latest tools. But you're not Google. You're not a startup that can rip and replace infrastructure every 6 months. You're in the messy middle, and you need infrastructure that serves your actual constraints, not your aspirational ones. So let's talk about how to make that happen. But before that, a word from our sponsor. Okay then, so first let's define what we mean by platform engineering in the context of mid-sized companies. Platform engineering isn't about adopting every project in the cloud native computing foundation landscape. It's not about having the same tooling as companies with thousands of engineers. Platform engineering for mid-sized companies is about building the minimum viable infrastructure that lets your product team ship faster, with less operational burden and fewer surprises. That last part, fewer surprises, is critical. When you're a mid-sized company, surprises are expensive. You don't have the depth of expertise to handle every edge case. You don't have on-call rotations that can absorb infrastructure incidents without impacting feature delivery. You can't afford to have your platform become the product. Here's the mental model I want you to adopt. Your platform engineering efforts should be invisible when they're working. The best platform is the one your developers barely think about because it just works. So this means making different trade-offs than enterprises make. Enterprises optimize for scale, flexibility, and handling every possible edge case. You need to optimize for simplicity, maintainability, and speed to competence. When a new engineer joins your team, how fast can they deploy something to production? If the answer is more than a day, your platform is too complex. Mid-sized companies also face a unique challenge with internal tools. You've outgrown the startup phase where everyone just uses the same 3 SaaS products, but you haven't reached the enterprise scale where you have dedicated teams building internal developer portals and service catalogs. So you're stuck in that awkward middle where you need internal tooling, but you can't afford to build everything custom. And that's where the build versus buy framework becomes essential. Before we get there, though, let's talk about the biggest platform engineering mistake I see mid-sized companies make. So let's address the elephant in the room, Kubernetes. And I'll put my hand up and say I use it in various places where the fit seems right. But I'm not saying that Kubernetes is bad. And I'm also saying that it's almost certainly overkill for your mid-sized company, and the operational burden it creates will quietly destroy your team's velocity. Here's what happens. You hire a talented engineer who worked at a company running thousands of microservices on Kubernetes. And they're horrified when they're deploying to VMs with shell scripts. They pitch the business on modernizing your infrastructure. Everyone nods along because, well, Kubernetes is industry standard, right? 6 months later, you've got a cluster running. Maybe you've migrated one service, but now you need to understand pod networking, ingress controllers, persistent volumes, fallback policies, and how to debug a crash loop back-off. Your infrastructure team of 2 people is spending half their time just keeping Kubernetes healthy. Meanwhile, your competitors are shipping features because they deployed to a VM with Docker and moved on with their lives. Here's the uncomfortable truth. Kubernetes solves you problems you probably don't have yet. It's designed for organizations that need to run hundreds of thousands of services, scale workloads dynamically across large clusters, handle multi-tenant infrastructure, operate in multiple regions or clouds simultaneously. If you're a 500-person company running 20 microservices, you don't have those problems. What you have is a small team that needs to ship features predictably without getting paged at 3 a.m. So what should you do instead? Deploy things to VMs. Use Docker for packaging because containers are genuinely useful for dependency management and deployment consistency. But you don't need orchestration. You don't need service mesh. You don't need operators managing operators. Here's a pattern that works incredibly well for mid-sized companies. You've got an application in a Docker container, which is great. That container runs on a VM managed by your cloud provider, an EC2 instance, a compute engine instance, whatever. You use infrastructure as code, so Terraform, Bicep, or something along those lines to define that VM and its configuration. No clicking around in consoles trying to remember what settings you've changed. For deployments, you write scripts. Bash is fine. Python if you prefer. The script pulls the new container image, stops the old container, starts the new one, runs health checks. You version control these scripts in your repository right alongside your application code. GitHub Actions or GitLab CI runs your tests, builds your container, pushes it to a registry, and runs the deployment script. That whole pipeline is visible in a single YAML file that junior engineers can understand. Is this sophisticated? No, not really. Does it work reliably for companies shipping millions of dollars in revenue? Absolutely. The key insight here is that operational burden compounds over time. That Kubernetes cluster might seem manageable today, but when you've got 3 engineers who understand it. But what happens when those engineers leave? What happens when you need to upgrade your cluster version? What happens when a pod gets stuck at a weird state at 2 a.m. and nobody on call knows how to debug it? Simple infrastructure has a hidden superpower. It's maintainable by a team that you'll have next year, not just the team that you have today. Now, of course, there's a counter-argument here. Someone always says, but Tom, we need to learn these modern tools to attract talent. Engineers want to work with Kubernetes. So I have 2 responses to that. First, engineers who only want to work somewhere because you have a specific tool are optimizing for resume building, not for solving your business problems. You want engineers who care about impact and not infrastructure tourism. Second, mid-sized companies have an advantage here. You can offer engineers ownership and impact they'd never get at a large company. At Google, you work on one microservice in a sea of thousands. At your company, an engineer can own an entire product area and see their work directly affect revenue. And that's a much better retention story than we use Kubernetes. So let's be clear, if you're at a point where you generally need Kubernetes, you've got the team size and the operational maturity, the scale demands, then absolutely use it. But if you're adopting it because it feels like that's what most serious companies do, you're making a mistake that will cost you months of engineering time and possibly some of the best people who would rather ship products than maintain infrastructure. Now, let's talk about the framework that will save you from most platform engineering mistakes. When to build versus when to buy. And the decision comes up constantly. Do we build our own deployment pipeline or do we use a managed service? Do we build internal admin tools or buy something off the shelf? Do we build our own observability stack or use a vendor? Now, most companies make these decisions emotionally. Someone on the team gets excited about building something, or someone else is frustrated with a vendor and wants to rip it out. But emotional decisions lead to regret about 6 months later when you realize that the thing you built needs maintenance, or the thing you brought doesn't quite fit the workflow. So here's a framework that I use, and it's based on 4 factors: maintenance burden, time to value, strategic differentiation, and exit costs. Factor 1, maintenance burden. For every piece of software you build, it creates an ongoing maintenance obligation. Dependencies need updates, bugs need fixes, new employees need documentation and training. If you build a deployment tool, you're now in the business of maintaining a deployment tool forever, or until you sunset it, which is its own project. The question you need to ask is, can your team absorb this maintenance burden without impacting product velocity? Here's a heuristic. If the thing that you're building will require more than 1 engineer week per quarter to maintain, you should be very confident about why you're building it instead of why you're buying it. Let me give you a concrete example. Internal admin tools seem like an easy build. You need a way for your operations team to manage customer accounts, run reports, trigger background jobs. How hard can it be? But here's what actually happens. You build 1 version of the week and it works. Then you need to add authentication. Then you need to add audit logging because of compliance. Then you need to add role-based access control. Then the UI needs to be mobile friendly. Then you need to add export functionality. Then you realize your database queries are slow and you need to optimize them. 18 months later, you've got a custom internal tool that consumes 6 months of engineering time and still doesn't work as well as something like Retool would have given you on day one. And that's not just hypothetical. I've seen like this pattern at multiple companies, including ones that I've worked at. Maintenance burden is often invisible when you're making the build decision. You're only seeing the exciting part, building something new. You don't see the boring part, which is maintaining it for years whilst your business priorities shift. Factor 2 is time to value. How quickly do you need this capability in production, delivering value? If the answer is now, you almost always buy. If the answer is we can wait 6 months to get exactly what we want, you might build. Mid-sized companies usually don't have the luxury of waiting. Your competitors aren't waiting, your customers aren't waiting, your board isn't waiting. This is where hosted services and SaaS platforms shine. You can have authentication set up in hours with Auth0 instead of weeks of building it yourself with all the additional security. You can have observability running today with Datadog instead of 3 months with a custom stack. The calculus changes if you've got very specific requirements that no vendor solves, or if you're in a domain where the tool itself is strategic. But for most platform infrastructure, CI/CD, monitoring, log aggregation, internal tools, someone has already solved your problem better than you will in your first iteration. Factor 3 is strategic differentiation. And this is the question that separates good build versus buy decisions from great ones. Does the capability differentiate your business, or is it table stakes? Your deployment pipeline, table stakes. Every software company deploys code. How you deploy doesn't make customers choose you over your competitors. Your internal fraud detection system, if you're a fintech company, that might be strategic. It might directly impact your unit economics and customer experience in ways that generic tools can't match. Your employee onboarding tool, probably not strategic. HR workflows are important, but they're not why customers pay you. So here's a test. If you do this exceptionally well, do customers notice and care? And so if the answer to that question is yes, then maybe consider building. If it's not, just go and buy something off the shelf. Most infrastructure is not strategic. It's necessary, but it's not differentiation. That CI/CD pipeline you're thinking about building, GitHub Actions exist. Your competitors are already using it. You building a custom alternative doesn't make your product better. Strategic differentiation also has team size component. If you're a 300-person company, you probably can't afford to have engineers building internal tools that don't directly support your core product. Every engineer you dedicate to platform work is an engineer not building features customers will pay for. The math changes at 3,000 people, but you're not there yet. Factor 4 is exit costs. The last factor is often overlooked. How hard is it to change your mind later? Some platform decisions lock you in. If you build a custom deployment system that's deeply integrated into your monorepo and CI/CD workflows, migrating away from that later will be a 6-month project. If you adopt GitHub Actions, switching to GitLab CI or build Kite later is a few weeks of work maximum. The configuration is similar. The concepts are the same, so that means that the exit cost, of course, is low. This factor should tilt you toward buying, not building, especially early in your platform journey. Buy the thing that has the lowest exit cost, even if it's not perfect. You can always replace it later when you understand your needs better. Custom builds have infinite exit cost because you can't just unsubscribe. You have to actively build a replacement. So how do you use these 4 factors? Here's the decision matrix. Build if maintenance burden is low relative to team capacity. You have the time to build thoughtfully. the capability provides strategic differentiation. Buying options have high lock-in or exit costs. You should buy if your maintenance burden would strain your team, you need value quickly, the capability is table stakes and not strategic, and multiple vendors exist with reasonable exit costs. And you should defer if you're not sure yet whether you need this capability, your requirements are still evolving rapidly, or the market for this capability is changing quickly. That last category, defer, is important. Not every platform decision needs to be made immediately. Sometimes the right answer is to live with a manual process for another quarter while you figure out what you actually need. Okay, let's talk about internal tools specifically, because this is where mid-sized companies waste an enormous amount of time. You've probably got requests piling up for internal tools. The ops team wants a better admin panel, the support team wants custom dashboards, the data team wants a better way to run queries, engineering wants a service catalog. Most of these internal tools don't need to be built. And that's just a hard fact. They need to be bought or configured. Platforms like Retool exist specifically to solve this problem. You can build internal tools by connecting your database, APIs, and services with drag and drop interfaces. What would take weeks to build custom takes hours in Retool. Is it perfect? No. Will your engineers complain that it's not as elegant as something you'd build? Probably. But will it deliver 80% of the value for 5% of the effort? Absolutely. And that's what matters. The key insight here is that internal tools don't need to be beautiful. They need to be functional. Your operations team doesn't care if the admin panel uses the latest React framework. They care if they can reset a user's password without filling in an engineering ticket. Your internal tools should have exactly one design principle: reduce the number of times people need to ask an engineer to do something manual. That's it. If your internal tool does that, it's good enough. Now, there are internal tools worth building, and here's a list. Developer productivity tools are generally genuinely custom to your domain. If you've got a complex deployment process that involves coordinating across multiple services, environments, and teams, and that process is specific to your architecture, then yes, build tooling for that. Integration glue between your specific systems. Sometimes you need to connect 3 SaaS products in a way that's unique to your workflow. A bit of custom code to shuttle data between Salesforce, your billing system, and your data warehouse? Absolutely reasonable. Performance-critical paths where vendors are too slow or expensive. So if you're processing millions of transactions and your observability vendor is charging you $50K a month, there may be a case for building something lighter weight. But be realistic about whether you'll actually save money after accounting for engineering time. Everything else, buy it, configure it, or use an internal tool platform. How about using Retool or similar platforms for anything user-facing that needs a UI? Use scripts and CLI tools for automation that runs in the background. Use your cloud provider's native tools for infrastructure management. Your internal tooling strategy should be boring, predictable, maintainable by whoever's on call. And now, a quick word from our sponsor. Okay, now let's talk about something that's not sexy but will save you more time than any platform tool: keeping your infrastructure organized, accessible, and documented. And this is something that can kill mid-sized companies: knowledge hoarding. One engineer knows how the deployment works, another engineer knows where the secrets are stored, a third engineer knows how to debug production issues. When those engineers leave, and they will leave, that's just how careers work. Your platform knowledge leaves with them. So you need 2 things: organization and documentation. Every piece of your platform should have an obvious home. Your infrastructure code lives in a specific repository with a specific structure. Your deployment scripts live in a specific place. Your runbooks live in a specific place. If someone needs to deploy a service, they should know exactly where to look. Not ask Sarah, not check Slack history, not dig through 3 different repos. They should look in the obvious place and find what they need. But this requires discipline, of course. When someone writes a new deployment script, it goes in the standard location. When someone updates infrastructure, they update the infrastructure repository. No one-off scripts living in someone's home directory, no critical documentation in personal notes. Documentation, of course, means writing things down, and like all the things. Every deployment process should have a runbook. Every piece of infrastructure should have a README explaining what it does, why it exists, and how to change it. Good documentation has 3 levels. The quick start, how do I deploy this service? How do I update this infrastructure? Give me the commands I need to run. The explanation, why is this configured this way? What problems does this solve? What did we try before that didn't work? And the reference, where are all the pieces? What are all the configuration options? How do I troubleshoot common issues? The thing is, of course, most teams only write the first level, if they write anything at all. But the second and third levels are what prevents knowledge loss when people leave. When someone on your team has to figure out something about your infrastructure that wasn't documented, they have to document it before moving on to the next task. There are no exceptions. Someone spent 2 hours figuring out why deployment failed in staging, they write a troubleshooting guide. Someone had to learn how to rotate database credentials, they document the process. Because, of course, this compounds over time. 6 months later, you've got a knowledge base that actually reflects how your infrastructure works, not how you wish it worked or how it worked 2 years ago. So having a quick discussion about access control and secret management, this is part of organization, but it's important enough to call out specifically. Your platform needs clear access control that's documented and audible. Who can deploy to production? Who can access production databases, and who can modify infrastructure? The answers to these questions should be written down and enforced by tooling, not just social convention. Use your cloud provider's IAM properly. Use secret management tools like AWS Secrets Manager or HashiCorp Vault. Make it impossible to accidentally do dangerous things and make it auditable, can't say that word this evening, when someone does authorize things. This isn't about trust, it's about reducing blast radius when something goes wrong. So finally, let's talk about automation and AI in the context of platform work. The principle here is simple. Automate anything that you do more than twice. Deployments, automated. Infrastructure changes, automated. Database migrations, automated. Security scans, automated. Every manual process is an opportunity for human error and an opportunity for knowledge to become siloed in one person's brain. Of course, the good news is that automation tooling has never been better. GitHub Actions, GitLab CI, Circle CI, maybe. Jenkins, if you're a sadist. I say in jest. Of course, Jenkins is still very good. All of these make it straightforward to set up pipelines that handle most of your automation needs. The key is to start simple. Don't build a complex deployment system with 50 configuration options on day one. Build the thing that automates your most common case, and then iterate. Your deployment script should probably do this. Run tests. Build the container. Push to registry. SSH to a production VM. Pull the new container. Stop the old container. Start the new container. Run a health check. Send a notification. And that's probably 50 lines of bash or 100 lines of Python. It doesn't need to be more sophisticated than that until you have evidence that you need more sophistication. Now, of course, AI and LLMs are changing automation in interesting ways because you can use an AI to help write these scripts. Instead of spending an afternoon fighting with the AWS CLI syntax, you describe what you want and let an LLM generate the first draft. You review it, you test it, you refine it, and that's a totally legitimate use of AI that saves time without introducing complexity. You can use AI to help write documentation. Take your deployment script, feed it to an LLM, and then ask it to generate a runbook. You need to edit and verify, but you've got a starting point that's better than a blank page. You can use AI to help debug issues. When something goes wrong in production, you can paste error logs into an LLM and get suggestions for what might be happening. It won't replace understanding your systems, but it can save time in the diagnostic process. The key with AI is to use it as a tool to reduce menial parts of platform work, script writing, documentation, debugging suggestions, without letting it make critical decisions about your architecture. And whilst it's getting better, AI is terrible at architecture decisions because it doesn't understand your specific constraints, your team capabilities, or your business context. But it's great at generating boilerplate, writing documentation, and suggesting solutions to common problems. So use it strategically. Let it handle the grunt work so your engineers can focus on decisions that actually matter. Of course, a word of caution about over automation because you can have too much. Because I've seen companies build elaborate automation systems that handle edge cases that almost never happen. The automation becomes more complex than the original manual process. The test for whether to automate something, will this save time over the next year, accounting for the time to build, maintain the automation? If you do something once a month and it takes 10 minutes manually, that's 2 hours a year. Building automation that takes 4 hours to create and an hour per quarter to maintain is a net loss. Just do it manually. But if you do something daily and it takes 30 minutes, that's 180 hours a year. So spending a day to automate it is a massive win. To be honest about the frequency and the pain of your manual processes before automating them. Let's talk about team sizing for platform work, because this is where mid-sized companies often get the math wrong. And here's a mistake. You think about the platform team size based on how many engineers you have, not based on what you're delivering. Someone says, we need a platform team of 5 people because we have 50 engineers. But what are these 5 people doing? Are they delivering capabilities that make those 50 engineers dramatically more productive, or are they maintaining infrastructure that exists because you chose complex tools? The right way to think about the platform team sizing is in terms of maintenance burden and new capability delivery. For every piece of platform infrastructure you operate, someone needs to maintain it. That maintenance has cost: security patches, version upgrades, incident response, onboarding new engineers, asking questions. So if you're running Kubernetes, you need someone who can handle cluster upgrades, networking issues, and all that operational complexity that comes with orchestration. And that's probably half a person's time, minimum. If you're running VMs with Docker, you need someone who can handle VM management and container deployments. That's maybe 10% of a person's time. The difference matters. It's the difference between a 2-person platform team and a 5-person platform team. It's the difference between spending 20% of your platform budget on maintenance and 50%. Now layer in new capability delivery. If your platform team is spending half of their time on maintenance, you can only spend the other half building new capabilities. You need to be ruthless about this calculation. So look at every piece of infrastructure you operate and ask, what is the ongoing maintenance cost? What is the cost to add new features or capabilities in the future? This applies to internal products as much as external facing products. That internal admin tool you built, it needs maintenance. It needs updates when your data model changes. It needs new features when the operations team workflow changes. If you're not accounting for those costs, you're accumulating technical debt in your internal infrastructure. For every engineer you dedicate to building new platform capabilities, you need at least 0.25 engineers dedicated to maintaining existing capabilities. If you've got 4 people building, you'll need 1 person maintaining. If your ratio is worse than that, if maintenance is consuming more than a quarter of your capacity, you've accumulated too much infrastructure complexity, and it is time to simplify. All right, we've covered a lot of ground, so let's bring it together. Platform engineering for mid-sized companies is not about adopting the same tools as companies with 10 times your headcount. It's about building infrastructure that serves your actual needs with the actual team you have. This means being skeptical of complexity. It means choosing boring, reliable tools over exciting, sophisticated ones. It means buying rather than building, unless, of course, you have a really good reason. And it means being honest about the ongoing costs of everything you operate. I put together a comprehensive build versus buy decision framework that walks you through every factor we've discussed today. And this includes a decision matrix for evaluating build versus buy for any platform capability, team sizing calculators that help you understand maintenance burden, a platform complexity audit that helps you identify where you've over-engineered, and right sizing guidance for common platform components. You can download it at engineeringevolved.com. It's free, it's immediately useful, and it will save you months of regret when you're making platform decisions. If you found this episode useful, share it with other engineering leaders who are fighting the same battles. We're trying to create a community of people who are willing to say, maybe we don't need Kubernetes, and actually mean it. Join me in the next episode where we dig into some more interesting engineering insight that will be practical, opinionated, and full of stories about what actually works versus what looks good in architecture diagrams. Until then, keep your infrastructure boring, keep your documentation current, and keep shipping. I'm Tom Barber. This has been Engineering Evolved. Thanks for listening.
Thanks for listening to Engineering Evolved with Tom Barber, where ideas meet innovation and leadership drives change. If you enjoyed today's episode, please leave a rating and review wherever you listen. It helps more leaders discover the show and keeps the evolution moving forward.